We have another example on the board. This time we have to find first the total admittance. In order to do so, I have to find the inductive susceptance. In order to find inductive susceptance, I'm going to find first inductive reactance. So I have formula X of L is equal 2 pi FL. So this is equal 2 pi times the frequency, and frequency is 10 to the 6th over pi hertz times the inductance, 500 microhenries. This is equal 1 kilo ohm, and of course X of L goes always with angle of 90 degrees. So this is my X of L. Next, I can find the inductive susceptance. So I can write over here, BL is equal 1 over X of L. So this is equal 1 divided by 1 kilo ohm and angle of 90 degrees. This is equal 1 millisiemens and angle of negative 90 degrees. So this is my inductive susceptance. If I have conductance and susceptance, I can find very easy total admittance. I have Y total equals G plus BL, okay, where G is equal 2 millisiemens and BL is equal 1 millisiemens and angle of negative 90 degrees. Use the calculator. You're supposed to obtain the value of 2.23 millisiemens and angle of negative 26.56 degrees. This is the total admittance in my circuit. Next, I'm going to find the total current. Someone is going to ask why you are looking for total current if we have to find IR and IL. Because this time I want you to practice the current division law. In order to use current division law, we're supposed to find I total. Of course, you don't have to do it, but I want you to practice it. So, I total is equal voltage source over Z total. Over here, someone can say that, but we don't have Z total. Don't forget that Z total is nothing else, just the reciprocal of Y total. So I'm supposed to write that voltage source over 1 times 1 over Z total is going to be equal I total, where voltage source over 1 is simply voltage source times 1 over Z total is nothing else, just admittance. So instead of 1 over Z total, I'm going to write Y total. This is equal, voltage source is given, I have 15 volts times Y total, we found it, is 2.23 millisiemens and angle of negative 26.56 degrees. Use the calculator and you're supposed to obtain the value of 33.45 milliamps and angle of negative 26.56 degrees. So this is the total current in the circuit. One more time, I need to find I total in order to use current division law. IR is equal I total, and I have G over y total, where I total is equal 33.45 milliamps and angle of negative 26.56 degrees. Open parenthesis, G is given, is equal 2 millisiemens, and we found Y total, which is equal 2.23 millisiemens and angle of negative 26.56 degrees. Everything is equal 30 milliamps. So this is the current which will go through the resistor. Next, we're supposed to find the current which will go through the inductor. So if IL equals I total times BL over Y total. Okay? I'm using the current division law. So my I total is equal 33.45 milliamps and angle of negative 26.56 degrees times BL, and BL we found is equal 1 millisiemens and angle of negative 90 degrees over Y total, which is equal 2.23 millisiemens and angle of negative 26.56 degrees. Everything is equal 15 milliamps and angle of negative 90 degrees. So this is the current which will go through the inductor. Now we're supposed to verify if our answers are correct. Okay, it's always good to check if these two currents are correct. So I have I total, I have to use KCL. Kirchhoff current law says that if you are going to add current which goes through the resistor and current which will go through the inductor, you are going to obtain I total. So let's check. I total is equal IR plus IL, where IR is equal 30 milliamps plus IL 15 milliamps and angle of negative 90 degrees. Use the calculator and you're supposed to obtain the value of 33.54 milliamps and angle of negative 26.56 degrees. Now we're supposed to compare this value, right? I mean the I total which we obtain from addition of two currents IR and IL with the value of the I total which we obtain, right, from Ohm's law by dividing voltage source over Z total. We got values which are very close to each other, okay? Even if this is 45 and this is 54, right? So we can say that they're close enough, and especially if angles are the same. So it means that our calculations at this point are okay. So we can continue. So next we're supposed to find power factor. Power factor is equal cosine of angle theta, and this angle is the angle which is next to Z total or Y total. So I have cosine of angle negative 26.56 degrees. This is equal 0.894, and I'm supposed to use word lag. But someone is going to say, but you have negative angle. Yes, but this angle is angle which is next to y, okay? Don't forget that we are talking about RL circuit, right? In this circuit, current total is going to always lag the voltage source by a certain angle. In our case, it's going to lag by 26.56 degrees. That's why I'm supposed to put word lag. Okay, this is very important that you remember that this angle comes from y total. So you don't supposed to look at the sign, just look at the diagram. Okay. So next, we're supposed to find QL. QL, reactive power, is equal IL to the second power times X of L, where IL we found is equal 15 milliamps, I have to raise this to the second power, times X of L, which is 1 kilo ohm. This is equal 225 millivolt ampere reactive. So this is the reactive power in my circuit. Next, I'm supposed to find the resistance in the series equivalent circuit. In order to do so, I'm supposed to write Z total, but we didn't find Z total, but we have Y total. So Z total, as you remember, is equal 1 over Y total, reciprocal of the total admittance. Next, you're supposed to set your calculators to the rectangular mode. Okay, so you have to make sure that you will get the answer in rectangular form. Y total is equal 2.23 millisiemens and angle of negative 26.56 degrees. Close parenthesis is equal 401.1 ohm plus J 200.5 ohms, where the real part is my RS and imaginary part is my X of LS. We need just RS. Next, I'm supposed to find LS. Okay? In order to find LS, I'm supposed to use X of LS. Okay? So, as you can see, RS is needed and also X of LS is needed. Okay? So I have formula which says X of LS is equal 2 pi FLS. Solve this formula for LS. So LS is equal X of LS over 2 pi F. This is equal X of L 200.5 ohms over 2 pi times 10 to the 6 over pi hertz. This is equal 100.25 microhenries. So this is the inductance in series equivalent circuit. Next, we can draw the series equivalent circuit. So I have voltage source, and voltage source has voltage 15 volts RMS and frequency 10 to the 6 over pi hertz. I have resistance Rs, which is equal 41.1 ohms, and I have inductor which has inductance 100.25 microhenries. Okay, so at this moment we can say that the problem is solved.